Good morning. Today's class, we're going to discuss about the topic of theory of computation. What are the central areas of TOC? Myself, Sharmila, Assistant Professor in CS Department in RMD Engineering College. There are three central areas. One is the complexity theory, and then next one is computability theory, and third one is automata theory. In that three theories, we're going to discuss briefly about what is the complexity theory and what is the computability theory and what is automata theory. The complexity theory is nothing but what makes some problem computational hard and other problem easy. So what is hard or how are we going to solve it? We don't know the answer, how to solve it, and we don't know the steps and procedures. For example, a problem is called as easy or difficult, whether it is efficiently working, whether it is hard. How we will decide? By solving it, by step-by-step procedure, we'll decide, and then we'll decide using that complexity. How complex that problem and how long it takes to reduce that problem as a solution. Correct? That main motivation of the complexity theory is classify problems according to their degree of computational difficulty, whether it is rigorous, whether it is easy, whether it is normal, whether it is medium. For example, in Sudoku game, we'll be having the simple level, medium level, and difficult level. There are three different levels. Maybe in some very difficult level will be their fourth stage, correct? Some simple level is nothing but it's simply we can solve. Those who know the Sudoku game, they can solve it. Medium level, it's a next level greater than that simple level. It's have some difficulty to solve the problem. It will take some set of examples, and we should already solve a simple problem, can solve difficult problem. And compared to the medium level, that is a very difficult level. It's an expert can solve that particular problem based on their experience. That is the measurement of complexity theory. That is the first theory. Second one is computability theory. Computability theory is nothing but which problem can be solved by a computer, which one cannot. Whether is able to solve it, whether we'll get a solution for it or not by the computer. Determining whether the mathematical statement is true or false. If it is possible to solve, we can make it as true. If it is not possible to solve, we make it as false. And naturally, for a solution, computers have some algorithm to solve it. For some problem, there is no algorithm to solve it. That performance regarding whether we can solve it or not we can solve it, that is called as computability theory. In that, the main motivation of the computability theory is classify the problem as being solvable and unsolvable. What is solvable means we can solve it easily by using some set of algorithm or some step, mathematical step, we can solve it, we can get a solution. Unsolvable means we don't have any algorithm to solve it, there is no solution to solve it. For example, how many stars in the sky? Is it answer is there? Can you solve it? No, it's not possible to solve the question how many stars are present in the sky. It's uncountable, unsolvable solution. So that is the second one, computability theory. Third one is automata theory. The automata theory deals with mathematical model of computation. What is mathematical model? In maths, we have some set of steps to solve the algorithm, to solve the Venn diagram, to solve the union problem. So we have a mathematical model for that computation. For example, the finite automata have text processing, compiler design, hardware design, context-free grammar, Turing machine. The Turing machine will do the design for adding of two numbers. For example, you have 2 plus 3, 5. So the Turing machine tape, you will store 2 divided by the delimiter 0 and 3 ones. That is for representation of 3. So you add 2 plus 3 is 5. In the Turing machine tape, finally you will store the value 5 as your output. That is the example for automata theory. The main motive of the automata theory is to determine power of different computation model to solve the problem using some mathematical model. That is the three main core area of theory of computation. The history of TOC is nothing but in 1930s they found out Turing machine, decidability, halting problem. In 40s and 50s they find out what is the finite automata machine, and in 1969 they introduced the intractable machine, that is NP hard problem. In 1970 they have as compilers, computation, complexity theory evolves. And then why this course we going to do? Why this course TOC? We know as a computer science students how to solve a data structure problem, how it works internally in the computer. That is the main idea of this course. How we can solve the problem by using a computer tapes, finite memory, how to store one, how to read that one, whether it's moving left, whether it is moving right, the data, and what are the mathematical model behind that. If you're adding a two number, what is the provoking there, what argument is going there, like that we're going to discuss internally. We are going to analyze the capability and limitation of a system. That is this main course idea. So here the Turing mission named by the Turing. He is an English mathematical person. He only invented the Turing test. Okay, the person, the photo I have showed is a Turing, the person name called as Turing. He introduced that, he invented that Turing mission. Okay, in today's class we have discussed about what is the three main core area of TOC and why we going to read TOC, what are the mathematical model available, how we can solve it, solvable or unsolvable. Next video we'll see the next topic about how the TOC works, what are the problems available. Thank you.